Let's finish 8.6 Day 1 by completing example B with coterminal and then converting from polar to rectangular at the bottom. Example B gives you an R value and a theta value that's in radians. If we sketch the graph for the original point, that means we're going to count out 3 circles, 1, 2, 3, and rotate to 2 pi over 3, like so. We end at that location, and like before, I'm just going to erase the path that gets us there, and you obviously don't have to draw that in if you can determine your end location. Connect from the pole to that end point. That's our original value. And then remember to come up with 2 other coordinates for the same point, meaning coterminal. We have to remember what it means to be coterminal for radians. You can keep your R value 3, or you can make it -3, and your theta value will either add 2 pi if we keep the same R value, or we'll add, you could actually add or subtract, I suppose, or add or subtract 1 pi if you change your R value to -3. So here's what I mean. If we keep our R value positive, and we want to have a coterminal answer with 2 pi over 3, if we take 2 pi over 3 and we add 2 pi over 1, that's just like how we got coterminal angles back in chapter 7. We simply need a common denominator. 2 pi over 3 plus, if we do 6 pi over 3, that would give us 8 pi over 3. That means 3 and then 8 pi over 3 would have the same end location as 3 and 2 pi over 3. Now, if we were to subtract that, meaning our angle would go clockwise, another possible theta rotation would be -4 pi over 3. That's another coterminal angle. If you wanted to change your R value and make it negative, you could do another possible option. -pi or -3 would mean we'd have to rotate all the way around to get to that point. That means we would take 2 pi over 3 and add 1 pi. Well, to get a common denominator, that would be 3 pi over 3, and that would just give you 5 pi over 3. We do have lots of options. You only need to write out 2 of them. The last concept we'll talk about in this lesson is converting from polar back to rectangular. Recalling our definition from Day 1's Part 1 lesson, we want to have our x value simply by taking r times cosine theta, and our y value is found by taking r times sine theta. Making sure that our coordinates would end up in the same quadrant on our system. Now 3, 30 degrees would be an answer we'll keep in what's called exact form. Can anybody think of why it would be exact? 30 degrees is from the unit circle. Yay! Oh, that unit circle. It just doesn't go away, does it? That's okay. We liked it. To keep it from, or to go from polar form back to rectangular, to get our x value, r is 3, and then we'll take cosine at 30 degrees. Think back to your unit circle, 30 degrees. The cosine value was radical 3 over 2. That means this would be 3 times radical 3 over 2. Technically, that's 3 over 1. If we multiply straight across, it's simply 3 times radical 3 over 2. That's the x-coordinate. The y-coordinate is r sine theta, 3 times sine 30 degrees. Sine at 30 degrees, anybody recall that coordinate? That was positive 1/2. 3 times 1/2 would just be 3/2. The ordered pair then is 3 radical 3 over 2, comma, 3/2. That would put you in quadrant 1 on your rectangular coordinate system. You'll know that it's going to be exact if any of those theta values in degree or radian is from the unit circle. But in our next example, 56 degrees wasn't one of our 16 specific locations. This is where you'll want a calculator handy. Also notice in the directions it says to the nearest thousandth. That means 3 decimal places. To get our x value, we'll take 4.2 times cosine 56 degrees. To get our y value, we'll take 4.2 times sine 56 degrees. Go ahead and enter both of those in and see what you get. I got x to be approximately 2.345 and y approximately 3.482. That would also be in quadrant 1, like our last ordered pair. To write that out then takes a little bit more time with all that decimal work. 2.345, comma, 3.482. That's all you do to convert from polar back to rectangular. For your worksheet today, make sure you're using all of your notes from day 1, part 1, and now this part 2 as a guide to complete. Once you're done, submit it for credit.